Hello everyone. So in this video, we shall discuss how to solve quadratic equations using the completing the square method. Now let's recall that the quadratic equation follows the form a times x squared plus b times x plus c is equal to 0, where a, b, and c are real numbers and a cannot be equal to 0. So this form is said to be the standard form of a quadratic equation. So when we solve for quadratic equations, we have to write it in the standard form first. However, in completing the square, it requires us to use the square root property. So what is the square root property? The square root property states that if x squared is equal to a constant, let's say b, then the value of x is positive, negative square root of b. So for example, if we have x squared minus 100 is equal to 0. So this is a quadratic equation where a is equal to 1, b is equal to 0 because there's no x term in this equation, and c is equal to negative 100. Now, this equation can be solved using the square root property, and we can do it by transposing negative 100 to the right side. So this gives us x squared is equal to positive 100. So this positive 100 here is our d in the following statement. And using this statement, so we can conclude here that x is equal to positive negative square root of 100, and the square root of 100 is equal to 10. So there are two values of x that will satisfy x squared minus 100 equals 0, and these are positive 10 and negative 10. So another example for this would be 3x squared minus 5 is equal to 0. So in order to solve for x here, we shall separate x squared from the rest of the coefficients and terms here. And we can do that by disposing negative 5 to the right side. So that gives us positive 5. And then we divide both sides by 3. So this gives us x squared is equal to 5 over 3. And then from this equation, we can apply the square root property. So x is equal to positive negative square root of 5 over 3. However, to rationalize this radical, we shall multiply both the numerator and denominator by 3. So this gives us x is equal to positive negative square root of 15. And then we have 3 times 3, which is 9. But if we get the square root of 9, that will give us 3 in the denominator. So our answer here is x is equal to positive negative square root of 15 over 3. Okay, another variation of the square root property is that whenever we have x minus, let's say, h quantity square equals k, then we can use the square root property by solving for x minus h. So x minus h is equal to positive negative square root of k. However, to solve for x here, we can transpose negative h to the other side. So this would imply that x is equal to h plus minus the square root of k. So we can apply this using the following example. So if we have, let's say, x plus 1 half quantity squared is equal to 5 over 4. So using the square root property here, so we can solve for x plus 1 half, and the right side will now be positive negative square root of 5 over 4. But this one will be x plus 1 half is equal to positive negative square root of 5 over 2, because square root of 4 is 2. And then we transpose 1/2 to the right side. So we get x is equal to negative 1/2 plus minus the square root of 5 over 2. Or we can write this as negative 1 plus minus the square root of 5 all over 2. Another example would be, let's say we have 2 times the quantity of x plus 1/3 quantity square is equal to 13 over 9. Okay, so here we can divide both sides by 2. So we get x plus 1/3 quantity square. And then 13 divided by 9 divided by 2 will be 13 over 18. And then if we apply the square root property, we get x plus 1/3 is equal to positive negative square root of 13 over 18. Now, this square root of 18, the 18 can be written as 9 times 2 or 3 squared times 2. So in this case, 18 is 3 squared over 2. So let's write it down there. So 13 over 3 squared times 2. Now, to rationalize this radical, the 3 square here can be extracted outside of the radical. So we just need to multiply both numerator and denominator by 2. So here we get x plus 1/3 is equal to positive negative square root of 13 times 2 is 26 divided by 3 square, 2 square divided by 6 because 3 square, 2 square, if we extract it outside of the square root, then we get 3 times 2, which is 6. And then transposing 1/3 to the other side, now we get x is equal to negative 1/3 plus minus the square root of 26 over 6. Or if we combine this into a single fraction, where 6 is the least common denominator, then we get 6 divided by 3 is 2 times 1, times negative 1 is negative 2. And then 6 over 6 is 1 times square root of 26 is square root of 26. Okay, so this is the square root property. So now we shall use this in solving for quadratic equations using the completing the square method. The completing the square will require several steps. So let's discuss the completing the square by using a particular example. Okay, so let's suppose that we have 3x squared plus 4x equals 4. So this is our quadratic equation. Okay, so we shall transpose 4. We shall write this in standard form first. So we get 3x squared plus 4x minus 4 is equal to 0. Okay, so the first step here is we're going to divide both sides of this equation by the coefficient of x squared. In this case, that's 3. So we will divide by 3. Okay, so dividing by 3 will require us to divide each of the terms here by 3. So we get x squared plus 4 over 3 times x minus 4 over 3 is equal to 0 divided by 3, which is 0. So the next step is to transpose the constant to the other side. So we write x squared plus 4 over 3 times x. And then we have positive 4 over 3 at the right side. So observe that I left a space at the left side. It's because we're going to add something here. So the question is, what should be added into the left side? So to determine it, we shall get the coefficient in the middle term, or the coefficient of x. So 4 over 3 must be divided by 2. So this means that 4 over 3, you multiply it by the reciprocal of 2, which is 1 half, and this gives us 2 over 3. And then this 2 over 3 must be squared. And the square of 2 over 3 is 4 over 9. So we shall add 4 over 9 at the left side of the equation. And then the quantity added to the left side must also be added to the right side. Okay, now, so the purpose of adding this constant to the left side is to make this expression here a perfect square trinomial. So a perfect square trinomial can always be factored as the square of a binomial. So x squared is a perfect square. It's the square of x, while 4 over 9 is also a perfect square because it's the square of 2 over 3. And then the sign separating these two will be the sign of the middle term here, which is plus. So this thing is factored as x plus 2/3 quantity squared. And then for the right side, we combine this into a single fraction where the LCD is 9. So 9 divided by 3 is 3. Multiplied by 4 is 12. And then 9 over 9 is 1. Multiplied by 4 is 4. So this gives us x plus 2/3 quantity square is equal to 16 over 9. Now observe here that we can use the square root property in order to solve for x plus 2/3. So x plus 2/3 is equal to the positive negative square root of 16 over 9. So this would imply that x plus 2 over 3 is equal to positive negative 4 over 3 because that's the square root of 16 over 9. And then solving for x, we transpose 2/3 to the other side, so we get negative 2/3 plus minus 4 over 3. So this will give us x equals negative 2/3 minus 4 plus 4 over 3, and x is equal to negative 2/3 minus 4 over 3. So combining into a single fraction, we get negative 2/3 plus 4/3 is positive 2/3. While for the other one, we have negative 2/3 minus 4/3, which is negative 6 over 3, which is equal to negative 2. So the solutions for this quadratic equation is 2/3 and negative 2. So this is how completing the square works. All right, so let's have another example. So for our last example, we're using the completing the square. So we have x squared plus 3x minus 2 equals 0. Now observe that the coefficient of x squared is 1. So there's no need to divide both sides of the equation. So we can just proceed to the next step, which is to transpose negative 2 to the other side. So we get x squared plus 3x, and then the right hand side will be positive 2. So again, observe that I left a space here because we're going to add something here and add something to the right side. So we get the coefficient of the middle term, which is 3. We divide it by 2, and then we square 3 over 2. That gives us 9 over 4. So we shall add 9 over 4 here, and we shall also add 9 over 4 to the right side. So the left side of this equation is now a perfect square trinomial, which can be factored as the square of the binomial x plus 3 over 2. And then for the right side, we will combine that as a single fraction. So 4 times 2 is 8. And then 4 over 4 is 1 times 9 is 9. So this gives us x plus 3 over 2 quantity squared equals 17 over 4. Now applying the square root property here, we get x plus 3 over 2 equals positive negative square root of 17 over 4. And this will give us x plus 3 over 2 is equal to positive negative square root of 17. And then the square root of 4 is simply 2. Okay, and then positive 3 halves will be transposed to the other side. So this gives us x is equal to negative 3 over 2 plus minus the square root of 17 over 2. So combining this into a single fraction, that gives us x is equal to negative 3 plus minus the square root of 17 all over 2. So therefore, our solution here or solutions here would be negative 3 plus square root of 17 over 2. And then the other one is negative 3 minus square root of 17 over 2. So these are our solution set for the problem. So this ends our video for solving quadratic equations using completing the square. And thank you for listening. And I hope that you can subscribe to my YouTube channel. Thank you again.